So we try and find maximum stresses and their direction. These maximum stresses we will call principal stresses. Okay, plane stresses or principal stresses. Okay, so direction of principal stresses is phi, this angle. So if this is, let me start here. This is the machine element, the point, with stress in x and stress in y. Okay, if we cut, let's say I cut like this. Okay, so I will have a new surface, which is this surface. For this surface, there will be normal stress and shear stress. Maximum stress or principal stress will happen at an angle of phi. Okay, here. So this is maximum stress value, principal stress, and this is shear stress. Okay. Okay, now formula to calculate plane stresses is this formula. Once you have your sigma x and sigma y and shear, you can calculate sigma 1 and sigma 2. We have two values because there is plus and minus. So you use plus, you get sigma 1, you use minus, you get sigma 2. Two values for principal stresses. For shear stress is basically this part of the formula, the second part of the formula. So shear stress is one value for maximum shear. Also can be calculated using sigma x, sigma y, and shear stress. If, for example, I give you a problem with one normal stress, that means you have stress in one direction only. You don't have stress in two directions. You only have sigma x, sigma y is 0. But if I give you stresses, two normal stresses in two Cartesian axes, then you must use them. Okay, so maximum shear and principal stresses, let me go back. This is very important. In this formula 313, we have sigma 1 and sigma 2. We have two principal stresses. Well, actually we have three principal stresses: sigma 1, sigma 2, sigma 3. But one of these sigmas is 0. So we calculate 2, and we know that the third one is 0. Okay? Okay, now we have example. In this example, we have beam subject to bending moment into two planes. When you have bending moment in two planes, you need to add them together according to this formula. So sigma is, because sigma from bending is MCI. That's when you have beam subject to bending. So what if we have bending in two planes? That means we have bending in this direction and then bending in this direction also, vertical and horizontal. Then you need to add them. If it is sigma x, then one of them will be in z direction and the other one is in y direction. you just add stresses, because you will have compression and tension, and then at the corner you will have compression and tension from the other plane. So this example will show you how to add these stresses.